like a Hellcat.
Hi guys, so welcome back sa ating YouTube channel. So today yung pangatlong lesson natin para sa ating abelian and cyclic group na playlist. So in this topic we will discuss about properties of cyclic group. So before ako mag-proceed dyan sa mga yan, so unahin ko lang na abisuhan kayo na hindi lahat ito ipoprove ko. So since hindi ko sure kung saan inabot yung inyong number theory, so I don't know kung ano yung depth ng number theory nyo. So I guess hindi ko kailangan i-prove lahat. So ipoprove ko lang yung mga possible. Kasi more likely lahat to may gamit ng mga number theory. Kasi may mga GCD na involved. So baka magulat kayo or magulantang sa mangyayari. Okay, so ang gagawin ko nang is magkakaroon ako ng mga illustration kung paano siya gamitin. Kasi lahat to gagamitin natin pag nagko-construct tayo ng lattice diagram ng mga group or ng group. Okay, so now that's of the properties. So before ako mag-start again, i-recall ko muna kayo sa mga napag-usapan natin na properties. So lagay ko na dito yung unang property or properties na nalaman natin is that the order of A is just equal sa the order of the cyclic subgroup generated by A. So this is for all A element of G. So yung order daw ng element A is just equal sa order nung cyclic subgroup generated by A or yung cardinality ng elements ng cyclic subgroup generated by A. So again, subgroup yun. Okay, so number 2. So ito hindi ko ito nasabi. The generators or the generators of C sub n are or is x, every x. So lagi ka lang every x in C sub n such that yung GCD ng x and n is equal to 1. So again, GCD ng x and n is equal to 1. So ano ibig sabihin? Kung meron kang C sub n, hanapin mo lang yung mga relatively prime dun sa n, tapos ayun yung mga generator. So for example, meron kang C sub 8. Okay, so ang mga generator nito, the generators are, so ito sure ako equal to sa 1. Kasi 1 is relatively prime to 8. Pangalawa, 3. So 3 is relatively prime to 8. Next is C 5. Sunod ay C 7. So yan yung mga generator. So the generator are 1, 3, 5, and 7. So ganun kasimple. Yan. So that is okay. So since lagay ko lang no, since ang GCD ng 1 and 8, ang GCD ng 3 and 8, ang GCD ng 5 and 8, ang GCD ng 7 and 8, so equal to, sorry, equal GCD ng 7, 8 is just equal to 1. Okay, so relatively prime sila sa isa't isa. So tandaan, napaka-importante yan. So at least bawas trabaho ka. So kunyari, meron akong tanong about C sub n. Again, applicable lang to sa C sub n. So pag tinanong ko ano generator, automatic gamitin mo na to. So check mo lang yung relatively prime, automatic ay na yung mga generator niya. Okay, so may dalawa na akong property na nabigay sa inyo. So napaka-useful na ito throughout sa buong course ng abstract algebra natin or sa mga pag-aaral natin. Now, let's have theorem 3.3.1. So every cyclic group G is abelian. So baliktad, no? So kanina or sa from previous video, nagkaroon ako ng abelian yung group pero hindi cyclic. Tama. So tama 'yon, hindi lahat ng abelian cyclic. Okay, pero sure ako na pag ikaw ay cyclic group, automatic ikaw ay abelian. Okay, so paano siya ipoprove? So check natin ha. So ito yung proof. So since alam natin na siya ay cyclic, so let A be the generator. Let A be the generator of G such that we can write a cyclic subgroup generated by A is equal to G. Okay? So let A be the generator of G. So now maglelet ako. So let X and Y. So naglet ako ng X and Y element of G. Okay? Such that si X ay equal kay A raised to M and si Y is equal to A raised to N. So for some M and N element of integer. So explain sir bakit nangyari. Sir, anong ginawa mo? Ano bang sabi ko pag generator? pag generator ka ng G, ang sure ko, kaya mong tawagin lahat ng element ng G. Gets mo? Again kung si A, generator ng G, so meaning, kaya niyang tawagin lahat ng elements ng G, suppose that X and Y, tapos ang gagawin mo lang, i-erase mo lang siya sa integral power. Anong klase integral power? M and N, which is element of integer. So, ang ginawa ko lang, si X, kaya niyang tawagin, si A, kaya niyang tawagin si X, pag ni-erase ko siya sa M. Si A, kaya niya tawagin si Y, o kaya niya maging si Y kung i-erase ko siya kay N. Yun yung ibig sabihin ng pagiging generator. So, ang ginawa ko, naglet ako ng X and Y element of G such that X is equal to A raised to M and Y A raised to N for some M and N element of integer. So, nagamit ko yung property ng pagiging generator. So, ngayon, anong gusto natin i-consider? So, note or consider X and Y or X asterisk Y. So, ano ba sabi? Ang goal natin, kailangan natin siya maging abelian. So, anong goal? I-asterisk ko yung X and Y, dapat ang result sa huli is Y is equal to Y, X. Kumbaga, magko-commute. Okay, so, consider natin sa X, Y. So, this is just equal sa A raised to M multiplied by A raised to N. So, again, asterisk lang yung tinutukoy na yan. Then, this is just equal sa A raised to M plus N. So, aware naman tayo dyan, no? Since parehas ng element, i-erase na lang natin siya. So, kunyari, meron kang a squared, then a cubed. Ang gagawin lang, a raised to 5 yun. Kaya yun yung gagawin natin. So, next, by property, we all know that a raised to m plus n is just equal sa a raised to m plus n. Kumbaga, nagbaliktad lang. Commutative kasi yung addition eh. Okay? Next, sa integration. So, next is, this is a raised to n asterisk a raised to m, which is equal sa ito yung y, then this is x. So, x y is equal to yx for all x and y element of G. So, G is abelian. Okay, and therefore, this is done. Okay, so ganun siya kasimple. So, again, ito ay yung way ko lang para ma-prove siya. So, more likely, halos lahat naman ng book ganyan yung prove para ma-prove na every cyclic group G is abelian. Pero, hindi totoo yung converse na every abelian is a cyclic group. Kasi nagkaroon tayo ng mga example na kung saan abelian pero hindi cyclic. Tandaan yun. Okay? So, yan yung ating ipoprove now. So, again, tandaan nyo na. Pag cyclic, automatic, abelian. So, sir, paano ko malalaman na cyclic pag may generator? So, meaning, si C sub 8, siya ay abelian. Bakit? May cyclic siya. Siya ay merong generator. May 1, 3, 5, 7. O, for example, sino yung mga tingin? Si C sub 4, ano yung generator ng C sub 4? Ang generator ng C sub 4 is si 1 and 3. Okay, si C sub 4 ang generator niya is si 1 and 3. Si C sub 5 ang generator niya is si 1, 2, 3, and 4. Okay, so si C sub 7 ang generator niya is 1, 2, 3, 4, 5, 6. Okay, so ang generator naman ni C sub 10 is si 1. C sub 10, no? Si generator ni C sub 10 is si 1, 3, 5, 7, and 9. Okay, tandaan yun yung mga relatively prime. So, napaka-importante yan. Okay, next is, punta tayo dito, no? Theorem 3.3.2, subgroups of cyclic group. So, every subgroup of a cyclic group is cyclic. Okay, so every subgroup of a cyclic group is cyclic. So, hanap tayo ng example ng cyclic group. So, from previous example natin, ano ba yung example natin? So, ito. So, consider natin si G na si 1, negative 1, I, and negative I, comma multiplication. So, ang sabi niya, yung subgroup daw niya is cyclic. So, aside dun sa sarili niya. So, consider natin to Consider si G kung saan ang laman is the set containing 1, negative 1, I, and negative I, comma multiplication. Okay, so we all know that the generator, or we all know that G is just equal sa I and negative I. So, alam natin na siya ay cyclic group. Okay, so yung dalawang subgroup niya is si 1, tapos si negative 1. Okay, ang sabi ng theorem na to, aside dito sa dalawa, alam natin cyclic na yan eh. Okay, so aside dito sa dalawa, subgroup niya rin tong dalawa. Okay, si 1, subgroup niya yan. So, sure ako, subgroup din niya subgroup din siya nung G natin. Okay, ito, subgroup din nung G natin. So, sure ako dyan. Okay, ngayon, ang sabi, ang tinutukoy ng theorem na to, ito daw 1 na to, saka itong negative 1 na yan, yung cyclic subgroup generated by 1 and 1 negative 1, pareha silang cyclic. Okay, so meaning, sila mismo to test natin kung meron silang generator itself na ma-generate yung element nila. Okay, so una kay 1. So obvious na tayo kay 1 kasi ang element lang niya is 1. So ang generator lang niya, actually, so sir, mako-consider mo ba generator ang sarili niya pag identity element lang siya? So medyo magandang tanong niya, no? Ako nakaisip nun. So ito implies na yung cyclic subgroup generated by 1 is just equal to 1. Okay, ngayon, ang tanong, generator niya bang maituturing si 1? Although alam natin cyclic siya, no? Kasi si 1 lang 1 raised to 1, 1 raised to 2, 1 raised to 3, laging babalik yung 1. Ngayon tanong, generator ba natin siya? Although sa definition, pasasabi natin generator pag dito. So again, I think mako-consider natin siyang generator ni cyclic subgroup generated by 1, ha. Again, consider mo lang siya as a group. So hindi na tayo nagpo-pertain dito. Kumbaga, ito ay the group of 1 comma multiplication na lang, sila lang. Okay? So ngayon, mako-consider ba natin na siya ay may generator? I guess, itong trivial subgroup na to is yes. Okay, may generator siya which is 1. Okay, kasi ang idea nga ng generator is, basta nakukuha ko lahat ng element. Ngayon, ang nangyari sa case na to is yung element lang niya is 1. So, no choice tayo na siya lang yung mismong magge-generate nung sarili niya, which is mako-consider natin siya as generator. So, therefore, this is cyclic. So, again, obviously, ito ay cyclic. Okay, so ito ay subgroup. Okay, next case, negative 1. So the cyclic subgroup generated by 1 is C1 and negative 1. So ngayon, punta tayo dyan. So consider natin na as group lang to isa. So ngayon, ang gagawin natin, titignan natin yung mga cyclic subgroup generated by 1. Ang cyclic subgroup generated by 1 niya is 1, syempre alam natin yan. Ang cyclic subgroup generated by negative 1 niya is just syempre negative 1 and 1. Okay, or 1 and negative 1, obviously. So therefore, ano generator niya? Ang generator ng negative 1 is a negative 1. Okay, so ayun yung binabagot ng theorem nito. Every subgroup of a cyclic group is cyclic. So lahat ng subgroup niya, that is 1, negative I, 1, and negative 1, lahat yan ay cyclic. Okay, kung consider mo sila as a group itself. Kumbaga, disregard mo na meron G na malaki. So consider mo sila as a group. Cyclic ba sila? Yes, cyclic sila. Why? Kasi nga subgroup sila ng cyclic group, which is yung group na to. Okay, so tandaan yung theorem na yan. So meaning, ano ba masasabi ni sir? For example, sa C sub 8, okay, sa C sub 8 na yan. So, sa C sub 8, another example natin, C sub 8, no? So, number 2 example, ito yung number 1. So, number 2, C sub 8. Okay, comma plus. Okay, so, ang mga subgroup dito, ang mga cyclic group dito, syempre, yung cyclic subgroup generated by 2, cyclic subgroup generated by 4, cyclic subgroup generated by 6, okay, cyclic subgroup generated by 3, so, na alam natin si 3 is generator, are all cyclic. Okay? So, cyclic din sila. So, ang mga subgroup na to, ng C sub 8, plus is cyclic din. Okay, tandaan. Kasi nga, si C sub 8 is a cyclic group. Bakit siya cyclic group? Kasi may generator siya, which is 3, 1, 5, and 7. Tandaan yun. Okay, so, tandaan, si 2, 4, 6 are also cyclic. So, consider kasama ko na rin to. Kasi siya itself yun. Okay, so, yun yung sinasabi ng theorem. Ayan, tandaan. Pwede mo tawagin tong theorem na to pag sure ka. So, for example, in-assume na yung let G be a cyclic group. So therefore, kung babanat ka sa subgroup, therefore every subgroup of G is cyclic. So meaning kaya mong gawin yung ginagawa ko kanina sa taas, yung ganitong pattern. So meaning meron siyang generator. So yun yung special case. So again, pag sinabi ko cyclic, alam mong may generator. Yun yung mga gagawin natin. Okay, so now proceed tayo dito sa sunod. Sorry, hindi ko masyado ma-highlight yung ating dapat gawin, ha. So hanapin ko lang yung next natin. Ano ba yung next natin? Yun. So, theorem 3.3.3, orders of element in finite cyclic group. Orders of element in finite cyclic group. So, orders of elements in finite cyclic group. So, saan ba natin i-apply ito? So, finite cyclic group, no? So, I guess, more likely apply natin ito sa mga C sub n. Pero hindi ko sinasabi lagi sa C sub n, na. Basta finite cyclic group. So, sa C sub n kasi, sure naman tayo lagi siyang cyclic. Lagi bang cyclic si C sub n? Yes, laging cyclic si C sub n. Bakit? Sure akong generator ni C sub n si 1. So, sa kahit anong value ng n, generator si 1. Number 1 tayong sure doon. Generator si 1. Okay, so si C sub n yung isa sa pinaka-example, best example ng finite cyclic group. So, example ng finite cyclic group natin, best example natin dyan is si C sub n. Okay, kasi nga, sure akong yung generator niya is 1. Regardless of any value of n, regardless ng kahit anong value ng n. Okay, now proceed tayo dito, no? let G be a finite cyclic group of order n. So yun, may order n. So eksakto tayo dyan, si C sub n. And let G be is equal to A. So meaning, cyclic siya, no? Let G be equal to sa cyclic subgroup generated by A. So meaning, ang ibig sabihin, pag nakita mo yung ganun, ibig sabihin cyclic siya. So again, let G be a finite cyclic group of order n. Although sinabi ng cyclic siya, tapos meron daw A na nagge-generate sa kanya. If B is element of G, then B is equal to A raised to S for S element of Z plus. Then the order of B is N over D, where D is the GCD between S and N. Again, para makuha mo, kung meron kang, ito lang goal lang. Kung alam mo kung sino yung generator, again kung alam mo kung sino yung generator, CB, so kung alam mo kung sino yung generator, tapos meron ka isang element, kung gusto mo kunin yung order ng isang element, ang gagawin mo lang is, hanapin mo yung generator, tapos yung order ng element gusto mo, yung order ng element na yun, equate mo doon sa generator raised to S, for S element of Z plus, tapos hahalampit mo kung ano yung S. And kung ano yung S na yun, na mag-repeat doon, then, ang order of B, para makuha natin hindi, ang gagawin naman, that is the GCD between yung S na nakuha mo, and N, tapos N over D, yung magiging GCD niya. So, for example, dito, is consider latency. So, example, or as for illustration, okay, example, let G be the group of Z sub 15, plus. Okay, assuming yung ganyan. So, sino yung mga generator nito? Ang generator nito, the generators are, so by property, the generators are, syempre 1, sino pa? 2, okay, 3 hindi, 4 yes, 5 hindi, 6 hindi, 7 yes, 7, 8 yes, 9 hindi, 10 hindi, 11 yes, 12 hindi, 13 yes, 14 hindi. Yes, sorry, generator siya. And yes. Okay, so meaning yan yung mga generator. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So, 8 yung generator ng C sub 15. Okay, so for convenient, para pinakamadali natin gawin dito, is, ang sabi lang, no, kunwari, ang gusto natin kunin dito sa order na ito, kunin natin yung order, or find the order of, pili tayo, for example, find the order of 10. Okay, gusto natin kunin yung order of 10. So, without using yung natutunan natin na 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, up to makuha natin yung E. No? Or, kunin natin yung cyclic subgroup generated by 10. Diba? Dalawa na yung way na para makuha yung order ng 10. So, para makuha yung order ng 10, it's erase mo siya sa N up to ma-reach na yung E. Pangalawa is yung i-generate mo yung element na magagawa ng 10 raised to 0, 10 raised to 1, 10 raised to 2, and so forth. Okay, so kung ilan yung element nun, yun yung order niya. So, without using yun, gamitin natin yung idea ng theorem 3.3.3. Okay, so ngayon, sa pagpili dito sa C sub n, assuming, ang pipiliin ko muna is si 1. Okay, so assuming, ang generator o yung napili kong A, latin is si 1. So, although, yung A latin is 1, ang B latin syempre is si 10. Kasi yun yung nahanap natin na order eh. The order of B is N over D. Okay, so meron akong A na 1 and B na 10. Ang sabi nun, then B is equal to AS. Okay, B is equal to AS. So, meaning, B is equal to AS. So, meaning, B is equal to AS. So, this implies na ano yung B? This is 10 is equal to 1 raised to S. Ngayon, anong klaseng S? Yung i-raise ko para lumabas is 10 using yung plus. So, anong S yun? So, obviously, ang S na yun is 1. So, meaning, S is equal to 10. Sorry. Okay, bakit? Kasi 1 raised sa 10, so 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equal to 10. So, anong klaseng S? Ang gagawin mo lang, hanapin mo yung S na yun. So, S natin is 10. Ngayon, ang sabi, the order of B is equal to N over D. Ang sabi, the order of B or the order of 10 is equal to N over D. Ano yung N? 15 over D. Okay? Where D is equal to the GCD between S and N. Where D is equal, so this is 15 over, ano yung GCD ng S and N? Ano yung S? This is 10, tapos 15. So, ano GCD ng 10 and 15? Ang GCD ng 10 and 15 is 5. So, this is 5. So, meaning, the order of 10 is equal to 3. Okay? So, again, pinakamadali para sa C sub n, piliin mo na lang yung generator na 1. Okay? Kasi si 1 raised to something, obviously, kuha mo agad. Okay, kuha mo agad kung sino siya. So, assuming, sir, hindi natin pinili si 1. Okay, sir, assuming hindi natin pinili si 1, pinili mo po, sir, si 2. Okay, so assuming ang pinili kong A, natin is si 2, tapos yung b pa rin natin syempre is 10. Okay, so ano mangyayari? Ang gagawin ko, 10 is equal to 2 raised to s. So anong klaseng s yung magre-raise sa 10? So obviously 2 raised to 5. Diba? S yan ha. So obviously s is equal to 5 dapat. Bakit? Kasi nga ang mangyayari that is 2 plus 2 plus 2 plus 2 plus 2 that is 10. So 5 2 that is 10. So again na ibang generator yung ginamit ko. Assuming hindi ko ginamit yung 1. So 2 raised to s, that is s is equal to 5. So meaning the order of 10, so check natin. So the order of 10 is equal to d, which is 15 over, this is 5 and 15. Okay, which is equal sa 15 over 5, which is also equal sa 3 pa rin. So this is the order of 10 is just also equal sa 3. So similar pa rin naman ng sagot. So kahit sinong gamitin mong generator, lalabas yan. Okay, basta sure ka pag ni-raise mo, alam mo yung S na lalabas. So again, yung S na yan is nagigets ko lang, nakukuha ko sa base dito. Kumbaga 2 raised to 5 meaning 2 plus 2 plus 2 plus 2 plus 2, that is 10. So walang pibilang. So pinakamadali talaga is 1, lalo sa C sub n. Okay, so ginawa ko example, best fit na mag-example dito para sa theorem na to, si C sub n. So I guess kung gusto mong hanapin yung order ng element natin, pwede mong gamitin yung theorem 3.3.3. Okay, the orders of element in a finite cyclic group. Okay, so again, hindi ko sinasabi na ito ay para sa C sub n. Pwede mo rin itong gamitin sa ibang element. So again, nag-best fit lang talaga si C sub n natin dito. So dapat finite cyclic group. Again, finite cyclic group. So tandaan yun. Now, let's have corollary. Okay, no? So, yan, ito naman yung medyo kakaiba. So sa C sub n, kaya mong hanapin yung mga generator. Tama? Again, sa C sub n, kaya mong hanapin yung mga generator niya. Tama, no? Kaya mong hanapin yung mga generator niya pag alam mo kung sino yung relatively prime dun sa n. Okay? Sa C sub n. Okay, what if hindi lang ba sa C sub n yung pinag-uusapan natin? Okay, so what if, kunwari, quaternion group, for example, meron siyang generator. So paano natin malalaman na bukod sa isang generator na yun, sino pa ibang generator? Okay, so now, ito yung sasagot sa katanungan na yun. So let G be a finite cyclic group. Okay, so let G be a finite cyclic group of order n, and let A be a generator for G. Then all the other generator of G are of the form A raised to R, where R, n is equal to 15. Again, A raised to R, where R raised to n is equal to 15. So, I guess, maghahanap tayo ng magbe-best fit dyan para dyan. So, I don't know kung sino yung mga generator, pero tatry natin sa quaternion na hanapin natin kung sino yung generator ng quaternion, kung may generator man sa quaternion. Okay, so try muna natin dito kay C sub n. So, kay C sub n, meron tayong unang way, no? So, kunin mo lang relatively prime. So, check muna natin kay C sub n. So, again A raised to R, where R, n is equal to 1. So, consider natin kay C sub 15 ulit. So, consider natin C sub 15. C sub 15, plus. Okay? So, assuming na ang alam kong generator, so sure tayo, no? Every C sub n, ang sure mong generator is 1. So, assuming alam natin generator is 1. So, generator is 1. So, assuming yan lang yung sure ko. Okay, anong gagawin? Ang sabi niya, then all other the generators of G are of the form A raised to R, where R raised to n is equal to 1. Where R, n is equal to 1. Where the GCD of R, n is equal to 1. So, paano yun? Ito yung gagawin nyo. Ito, the cyclic subgroup generated by 1 is equal to the set containing 1 raised to 0, 1 raised to 1, 1 raised to 2, 1 raised to 3, 1 raised to 4, 1 raised to 5, 1 raised to 6, 1 raised to 7, 1 raised to 8, 1 raised to 9, 1 raised to 10, 1 raised to 15, 1 raised to 11, 1 raised to 12, 1 raised to 13, 1 raised to 14, and 1 raised to 15. So, hanggang dyan lang kasi alam ko na order 15 siya eh. So, again, order 15 yan. Ano yung n natin? Ang n natin dito is 15. Okay, so ang gagawin mo daw, yung naka A raised to R. So, meaning generator raised to R, where R, N is equal to 1. So, meaning, check mo lang yung mga exponent. Okay? Lahat ng exponent na kung saan relatively prime sa 15 ay yun yung mga generator. So, for example, una si 1 raised to 1. So, obviously, alam na natin siya. Okay? 1 raised to 2. Obviously, kasi 2, 15. 1 raised to 3, 3 and 15 hindi. 1 raised to 4, yes, kukunin natin yan. 1 raised to 5, hindi. 1 raised to 6, hindi. 1 raised to 7, yes, kukunin natin yan. 1 raised to 8, kukunin natin yan. 1 raised to 9, hindi. 1 raised to 10, hindi. 1 raised to 11, kukunin natin yan. 1 raised to 12, hindi. 1 raised to 13, kukunin natin yan. And 1 raised to 14, kukunin natin yan. Kasi relative. 1 raised to 15 is 0 ulit yan. Babalik tayo doon. Okay, now, therefore, the other generators are in the form, syempre di ko na kunin 1 raised to 1 kasi 1 raised to 1 is 1. So kunin ko na si 1 raised to 2, 1 raised to 4, 1 raised to 7. So 1 raised to 2 is 2, 1 raised to 4 is 4, 1 raised to 7 is 7, 1 raised to 8 is 8, 1 raised to 11 is 11, 1 raised to 13 is 13, and 1 raised to 14 is 14. So, tama ba tayo ng generator base na nakiluwa natin kanina? That is 1, 2, 4. That's 1, 2, 4, 7, 8. 7, 8. So, 11 to, no? 1, 2, 4, 7, 8, 11, 13, and 14. So, ayan yung other generator. So, hoping na nakatulong tong part na to. So, again, hindi lang applicable to sa CSAB 15. So, ngayon, ito try natin kung may generator si quaternion group. So, I guess, stop ko yung video saglit. Tapos, hahanapin ko muna yung generator ng ating quaternion group. Tapos, hahanapin natin yung other generator niya kung meron siyang generator. Hi guys, so, yun. Medyo chinek ko, no, sa quaternion group. Pag check ko, wala akong nakita na generator niya. Although, hindi ako sure. Baka mali lang yung compute ko. So, I guess, kunin na lang natin yung pinaka-sure tayo. Which is yung G natin, yung kanina. Yung G is equal to the set containing, the set containing 1, negative 1, I, and negative I. And comma multiplication. So, we all know that I is a generator nito. Tama. So, we all know that I is a generator. So, verify natin kung makuha natin yung negative I. Okay, so, we all know that I is a generator. So, I is a generator. So, anong gagawin natin? Kung natin yung cyclic subgroup generated by I. So, una is I raised to 0, I raised to 1, I raised to 2, I raised to 3. So, we all know ang N nito is 4. Okay, so assuming yan ay natapos natin dyan. Okay, so kung mapapansin mo, ang mga R, ito kasi yung R eh. Yung mga R na kinuha natin GCD with 4 is just C1 and 3. Okay, so meaning I lahat yan. Sorry, I to lahat. I to. So meaning sino yung mga yon? So aside from I raised to 1, although siya na yung nakuha, ito yung isa. Okay, kasi yung 3 and 4, yung GCD ng 3 and 4 is 1. Okay, so since GCD ng 3 and 4 is 1, so meaning yung I raised to 3 is also a generator. So ano yung I raised to 3? I times I is negative 1 times I is negative I, which is equals to negative I. So tama yung theorem o yung corollary na to. So again, yung corollary na to is para ma-determine mo yung other generator niya, which is ayan. So again, yung something na binibilugan ko lang. So tandaan yung way ng corollary na to. Okay, so next natin is yung ating, tuloy ko na ito. Okay, theorem 3.4. So next video about Euler, so Euler or Euler P function. So in this video pag-usapan na, so in this video. So ito muna, no, in theorem 3.3.3.4, the number of subgroups of a cyclic group. So let G be, so again, the number of subgroups of a cyclic group. The number of subgroup. So kailan yung number of subgroup ng isang cyclic group para malaman natin kailan. Let G be a cyclic group. Okay, where G is equal to the cyclics generated by A, and G in the order of G is N. If H is a subgroup of G and H is equal to D, or the absolute value or the order of H is D, then D divides N if K divides N. There exists, ulit ka lang ha, the order of G is equal to N and H is a subgroup of G and H is equal to D, then D divides N. If K divides N, then there exists exactly one subgroup of G of order K. Okay, so of order K. So ano ba yung gagawin natin? Ano ba yung purpose dito? So ang purpose lang dito is kunin mo yung order, hanapin mo yung mga divisor. Okay, meaning yung mga subgroup na yun ay yung order ng mga subgroup niya. Again, ang gagawin natin dito, for example, is si C sub 15. Okay, so consider ko ulit si C sub 15. C sub 15, plus. Ang N natin dito is 15. Okay, so kunin mo yung divisor ng 15. So from number theory, ano ba yung mga divisor? Ang mga divisor is yung sarili niya. So yung divisor of 15. So kunin natin yung divisor of N. So kunin mo yung divisor of 15. So ang divisor ng 15 is una si 1. Okay, sunod si 3. Sunod si 5. So again, na divisor. 15 divided by 1 is 15. 15 divided by 3 is 5. 15 divided by 5 is 3. 15 divided by sunod is 10. Hindi pwede. Okay, and lastly this is 15. Okay, so meaning may apat siyang divisor. So meaning yung mga subgroup, okay, yung mga subgroups o yung order ng mga subgroup ng C sub 15 is una, order 1, pangalawa, order 3, pangatlo, order 5, panglima, order 15. So hindi na sinasabing apat yung subgroup niya. Actually, madami siyang subgroup kasi yung cyclic subgroup generated by 0, 1, 2, 3, up to 14, nakakapag-generate ng element. Pero mapapansin mo, may mga possible equal doon. Again, mapapansin mo may mga possible na equal doon. So I guess ituturo ko na lang yun para malaman yung mga yun. So again, ang sure ko lang dito, para malaman mo yung subgroup na yun, so ito yung subgroup, yan yung order ha. So yung subgroup na yun, para malaman mo kung sino yung isa doon, is ang gagawin mo, i-divide mo yung n sa kada dito. Okay, kunyari 15 divided by 1, 15. So meaning, yung cyclic subgroup generated by 15, ang order niya is 1. Next, 15 divided by 3 is 5. So, yung cyclic subgroup generated by 5, ang order niya, 3. Next, 15 divided by 5 is 3. Yung cyclic subgroup generated by 3, ang order niya, 5. Then, 15 divided by 15, this is 1. So, ang subgroup, yung cyclic subgroup generated by 1 na may order 15, which is alam natin siya ay generator nung C sub 15, ang order niya is 15. So, tama naman. Ngayon, check natin kung 1 lang yung order nito. So this is just equal sa 15 raised sa 0. So order 1 no. So 15. So 15 raised sa 0. So 15 raised sa 0, automatic 0. So this is 0. So meaning this is just cyclic subgroup generated by 0. So tama. Okay, so equal lang silang dalawa. Actually ito yung, so, di ba, ito si 15. So, equal lang siya dito kay cyclic subgroup generated by 0. So, parehas sila. Okay, kasi mag-start tayo sa 0 eh. Si 15 raised sa 0, 15 raised to 1. So, 15 raised sa 0 is 0, 15 raised to 1 is 15. Okay, so, ayan yung sunod niya. So, check ko lang sa sunod na element. Next is, ay, sorry. May na-realize ako. Again, bansin mo yung cyclic subgroup generated na may order 1 is just 0. Wala tayong cyclic subgroup generated by 15 sa C sub 15. Bakit? Ang element lang nito is 0 to 14. Again, ang element lang nito ay 0 to 14. So meaning wala tayong, so hindi mo pwede apply. So una, pag nakita mo 1, automatic yung identity element. Again, pag nakita mo order 1, automatic identity element, which is yung cyclic subgroup generated by 0. So sorry about dito, mali. So again, yan lang yung medyo na iba. Okay, so sa order 1, automatic si identity element. Pagdating ng order 3, punta ka na doon. 15 divided by 3, yan na si order 5. Yan na si cyclic subgroup generated by 5. So check nga natin to, kung tatlo lang yung element nito. So check natin, no? So this is 5 raised sa 0, 5 raised sa 1, 5 raised sa 2. Tapos this is just 5 raised sa 0 is 0, 5 raised sa 1 is 5, 5 raised sa 2 is 10, 5 raised sa 3 is 15, modulo 15, that is 0. So babalik. Okay, so ilan yung element? 1, 2, So, order 3. So, tama tayo doon. Ngayon, check natin to. Order 5 ba to? This is 3 raised sa 0, 3 raised sa 1, 3 raised sa 2, 3 raised sa 3, 3 raised sa 4. So, check natin kung dyan titigil. So, this is just equal sa 0, 3, 6, 9, 12, 15 sa 3 raised to 5, which is babalik. So, ilan yan? 1, 2, 3, 4, 5. 5 yan. Okay? So, tama si sir nang nakuha. So, meaning, ang order ng cyclic subgroup generated by 5 is 3. Ang cyclic subgroup generated by 3 is 5. Ang cyclic subgroup generated by 1 is 15 kasi siya ay ating generator. Pagdating kay 1, automatic yung identity element. So, hoping na nagets mo tong number of subgroup of cyclic subgroup. So, again, the number of subgroup of cyclic subgroup is determined by the divisor. So, ilan yung divisor? 4. So, meaning may 4 lang siyang subgroup. Okay, so yun na yung mga number. The number of subgroups of cyclic group is may 4 lang siya. So ito yung mga yun. Sir, paano yun? May makaparehas to eh. May makaparehas pero isa na lang sila. Kumbaga parang kunyari, the cyclic subgroup generated by 2 is equal to the cyclic subgroup generated by 1. Iisa na lang silang elements eh. Iisa na lang silang subgroup eh. Okay, so hindi mo sila pwede i-consider na magkaiba. Kasi parehas sila ng element. Okay? Kasi aware ka na yung cyclic subgroup generated by 1 is equal to cyclic subgroup generated by 2. Equal din to kay cyclic subgroup generated by 3, 4, 5, 4. Equal din na kay 4. Okay? Equal din yan kay 7. Equal din yan kay 8. Equal din yan kay 11. Equal din yan kay 13. Equal din yan kay 14. So, iisa lang sila lahat. Okay, so kaya nga sinabi niya na may 4 lang siyang subgroup na ito yung mga order. Okay, sino yung mga subgroup na yun? So, i-represent mo na dun sa mga original. Siyempre, yung may order 1 sa identity element, yung may order 3, yung na-divide mo dun, yung may order 3, yung na-divide ko dun, yung may order 1, yung na-divide ko. Yung may order 15, yung na-divide ko dun, which is 1. So, itong 1 na to, nire-represent na niya lahat yan. Iisa na sila lahat yan. Ultimo si C15. Okay, so tandaan yan. So, that's all in this video. So, sa next video, pag-uusapan natin si Euler P function. So, again, hoping na tandaan mo yung mga pinag-usapan natin, especially itong mga finite cyclic group. So, magagamit kasi natin lahat to. Although, although ipapakita ko ulit siya kung paano gamitin sa mga next video. So, again, thank you for watching. Hoping na nag-enjoy ka.